People often ask me about how do you, do these things, SpaceX, Tesla, and they usually start from a false premise. They start by asking about probability. They say, what was the probability of success for SpaceX when you started? And I was honest. I said, I thought it was less than 10%. I thought we would fail. I thought both companies, Tesla and SpaceX, would fail. They say, what was the probability of electric cars succeeding? Very low, extremely low. History is a graveyard of car companies. In the US, in the last 100 years, the number of car companies that have been successful is 2, Ford and Tesla. Every other company has gone bankrupt. So if you start with the question, what is the probability? You will never start. They are starting in the wrong place. They are confused. They confuse low probability with impossibility. There's a quote, a saying that I find very useful. It's a kind of algorithm. The first step is to establish that something is possible, then probability will occur. This is the most important thing I think I can share. This isn't a cheesy motivational quote. It's not something you put on a poster. It's a physics framework for viewing the world. It's an engineering process. Tonight, I want to unpack that. I want to talk about what it really means. Because if you understand it, you can re-architect reality to your will. The psychological framework of probability, breaking analogical thinking. We, the human brain, it has evolved to conserve energy. It's lazy. It looks for shortcuts. The biggest shortcut we use is what you might call reasoning by analogy. This is how most people operate in the world. They look at how something has been done before, and they essentially copy it maybe with small incremental changes. We do this because it's like what other people are doing, or it's like how it's been done in the past. And that's fine. For most of life, it's fine. You don't need to reinvent everything. But there's a problem, a big one. If you only reason by analogy, you will never achieve a breakthrough. You will never create anything truly new. You will be stuck. You'll be stuck in a local maximum and never find the global maximum. This is why people said SpaceX was impossible. When I said, I want to build a rocket company, what did they say? They said, you can't do that. Why? Because only nations do that. Only NASA. Only Roscosmos. No private company has ever launched a liquid-fueled rocket to orbit. They were reasoning by analogy. They were looking at the past and extrapolating it into the future. When we said, we want to make rockets reusable, they said, that is impossible. Why? Because no one has done it. Because the experts say it's too hard. Because they've always been thrown away. Reasoning by analogy. This is the first psychological wall you have to break. You have to throw it away. You have to replace it with physics. Step one, possibility is a binary physics question. The first step, establish that something is possible. What does this mean? It means you have to stop asking who has done this before and start asking a completely different question. The only question that matters is, does this violate the fundamental laws of physics? That's it. Possible is not a scale. It's not 10% or 50%. It is a yes-no answer. A binary. A reusable rocket, a rocket that takes off and then lands back on its launch pad intact. Does physics allow this? Yes. Do the laws of thermodynamics allow it? Yes. Fluid dynamics? Yes. Gravity? Obviously, yes. We've seen it in science fiction movies for 50 years. Artists have drawn it. The problem is just engineering. It does not violate any fundamental physical laws. Okay? So it's possible. Step one, done. An electric car, a beautiful, fast car that can accelerate faster than a Porsche and has a 500-mile range. Does physics allow it? Yes. How much energy can you store in a battery? At what efficiency can you convert that energy into rotational force? Physics says yes, absolutely. Okay. So it's possible, a brain-computer interface, extremely high bandwidth, that can stream megabits of data directly from your brain. Does physics allow it? Yes. Electrophysiology allows it. Signal processing allows it. If the answer is no, it does not violate the laws of physics, then you have completed step one. You've established possibility. And most things that people say are impossible are actually physically possible. Step two, probability is an engineering problem. Now for the second part of the quote, then probability will occur. This is the part everyone misunderstands. They think it means you believe, and then somehow the universe will grant you a better probability. No. doesn't mean probability will just happen. It means probability becomes a solvable variable. Once possible is established, probability is just a function. Probability is a function of engineering: effort, capital, innovation, and time. Probability is not something you find, it is something you create. I look at the future not as a set path. I look at it like a branching stream of probabilities, like a tree. There are millions of branches. And you can take actions, you can nudge a probability branch, you can accelerate some things, slow down others, you can introduce something new into the probability stream. When I said the probability of SpaceX succeeding was 10%, that was my initial estimate of our ability to solve the engineering problem before we ran out of money. Our job as engineers was to act as a force, a vector to push the timeline towards the future we want, to take that 10% probability branch, and by sheer force of will, by clever engineering, by iteration, to drag it up to 20%, then 30%, then 50%, and finally get it close enough to 100% that it becomes reality. So when people said SpaceX was impossible, they were wrong. It was just extremely improbable. And our job was to change the probability. The question is not what is the probability of success. The question is how hard, how smart, and how long do we have to work to create the probability of success? It's a fundamental mental shift. It moves you from being a passive observer to an active agent of reality. Deconstructing impossible, the tool, first principles thinking. Okay, so how do you know what's physically possible? How do you know what is a fundamental truth and what is just an assumption people have been copying for 50 years? You have to have a tool, a method. For me, the physics framework is the best one. I call it first principles thinking. I think it's one of the best ways to think about problems. It was talked about by Aristotle. A first principle is the first basis from which a thing is known. It means you have to boil things down. You have to strip a problem down to its most fundamental truths. The axioms, the basic building blocks that you cannot deduce any further. And then this is the key, you reason up from there. It's the exact opposite of reasoning by analogy. Let me give you a couple of examples. Case study one, the impossible rocket. When I started SpaceX, my original idea was I wanted to do something to get people excited about space. I thought humanity needed to expand out there. So the idea was Mars Oasis. We could put a small greenhouse, some plants, maybe mice, on Mars, just to show life could exist. That was the idea. So I went to Russia. I went to Russia to try to buy some refurbished intercontinental ballistic missiles. And I thought we could use those. I went there with a few friends. First time, 2001. They thought I was crazy. They thought I was a dot-com rookie. They looked at me. They literally spat on me. I went back. Then I went back again. A year later, this time I brought more money, more talent. This time they were a little more serious. We drank a lot of vodka. I said, I want 3 ICBMs. They gave a price, crazy price, tens of millions of dollars each. And on the flight back, I was angry. But I was also thinking, I was running the numbers. And I turned to my team and I said a sentence. I said, I think we can build the rocket ourselves. Why did I say that? Was I insane? No. It was first principles thinking. While they were mocking me, I was asking the fundamental question, what is a rocket made of? What is it made of? It's made of aerospace-grade aluminum alloys, some titanium, copper, and carbon fiber. That's the structure. Then you have electronics, engines. Next question. The important one, what is the value of those materials on the commodity market? And I actually did this. I did the math. And it turned out the raw material cost of a rocket was only about 2% of the typical sales price. 2%. So what made up the other 98%? It was just inefficiency. It was a giant bureaucracy of aerospace contractors who had been reasoning by analogy for 50 years. They were stuck. They had no incentive to innovate. The industry said a rocket costs $65 million. Physics said the materials cost about $1.3 million. Who do I believe? I believe physics. So the impossible problem of building a rocket was actually just a problem that aerospace contractors were very, very inefficient at manufacturing. The economics said that if we could build it smartly, vertically integrate, and critically reuse it, we could drop the cost of launch by an order of magnitude, maybe 2. That's how SpaceX started. It didn't start from hope. It didn't start from a dream. It started from a calculation, a first principles calculation. Case study 2, the impossible battery. The same thing, the exact same thing happened with Tesla. People, the experts, said the same thing about electric cars. They wrote volumes of articles about how we would fail. They said EVs would never work for one reason, the battery. They said batteries are too expensive. They said historically batteries have cost $600 per kilowatt hour. It will never get much better. That is reasoning by analogy. They are taking a historical data point and assuming it's a law of physics. So we applied first principles thinking. The basic question, what are the material constituents of a battery? What are they? They are cobalt, nickel, aluminum, carbon, some polymers for separation, and a steel can. That's what's in it. Next question, what is the spot market value of those things on the London Metal Exchange? And if you add them all up, guess what it is? It comes to about $80 per kilowatt hour. $80 compared to the $600 the experts said. So again, the impossible problem of electric cars was just a false assumption. It was just a legacy of people copying each other's designs with small incremental changes. It was obvious that you just need to find clever ways to take those raw materials, combine them into the shape of a battery cell, and you can have batteries that are much, much cheaper than anyone realizes. That's what we did. That's the Gigafactory. First principles thinking it's a tool, it's a crowbar to break the tyranny of the experts. The experts will always tell you something is impossible because they are reasoning by analogy. They're defending their legacy knowledge. You have to trust the physics. Physics never lies. The SpaceX story building the impossible rocket. So we started SpaceX. We knew from first principles that physically it could be much cheaper. Building a rocket was hard, extremely hard. But that wasn't the real impossible idea. The impossible idea, what one people really laughed at, was making it reusable. Before SpaceX, the standard practice of the aerospace industry was to throw the rocket away after every single use. Just imagine that. Imagine you fly on a Boeing 747 from Los Angeles to New York. And when you land in New York, you get off the plane and they push the 747 into a scrapyard. They throw it away. It's insane. It's so dumb. What would a ticket cost? $500 million? No one could afford to fly. But that is exactly what the space industry did. For 60 years, they were building a Ferrari for every launch when maybe a Honda Accord would do. The entire industry was built on the analogy that rockets are expendable. Because the space shuttle tried to be reusable, and it was so complex and expensive that everyone learned the wrong lesson. They learned the lesson that reusability is expensive. No, the correct lesson was reusability that way is expensive. So we applied our framework. Step 1, does physics allow for landing a rocket booster vertically on a landing pad, maybe on land or at sea? Yes. Does physics allow it to re-enter the atmosphere, use its own engines to slow down and land softly? Yes. Does it violate any laws of thermodynamics or dynamics or gravity? No. Okay. So it's possible. Step 1 is done. Now step 2, the engineering problem. How do we make the probability occur? And that turned out to be ridiculously hard. Manufacturing probability, the algorithm of failure, and iteration. Once you enter step 2, you are in the realm of engineering, and engineering is about failure. If you are not failing, you are not learning. There's a mantra we have at SpaceX, we repeat this all the time. If things are not failing, you are not innovating enough. Think about that. Most companies, most organizations, most people are wired to avoid failure. They have a huge bias, a cultural bias against taking risks. Failure is bad. If you fail, you get a bad performance review. But think about what that really means. If you are Not failing, it means you are in your comfort zone. It means you are reasoning by analogy. You are doing what you know will work. And if you are doing what you know will work, then by definition, you are not innovating. You are repeating the past. Failure is not an option, it is a prerequisite. Failure is irrelevant unless it is catastrophic. I look at it like baseball. If you're a baseball player, you don't care about any individual at-bat. If you strike out once, who cares? What you care about is your overall batting average. Your goal is to maximize the net useful output from your set of actions. Some actions will fail, some will succeed. As long as your net useful output is positive, and critically it is increasing, then you are winning. The Starship explosions, we had a lot of spectacular explosions. They were great. The media, they said, oh, failure. SpaceX failed, Elon's rocket blew up. No, that's not failure. That's a learning opportunity. That's rapid data acquisition. Every time a Starship blew up, we got terabytes of data about exactly what went wrong down to the millisecond. We learned something, we fixed it, we iterated. The real danger, the much bigger danger, is not failure. The bigger danger is stagnation. It's the danger of being so afraid of failure that you stop trying to do hard things. You stop innovating. So how do you manage failure systematically? How do you manufacture probability? At SpaceX and Tesla, we've developed a process, a 5-step engineering algorithm. This is how you do it. The 5-step algorithm for manufacturing probability. It's very simple to say, but very hard to do. Step 1, make your requirements less dumb. Your requirements are definitely dumb. That is a safe assumption. No matter who you are, no matter what you're doing, the requirements and constraints you have are dumb. They might have been given by a smart person. But everyone is wrong to some degree. Your aspiration is to be less wrong. And it's especially dangerous if a smart person gives you the requirements, because you might not question them enough. You just accept them. A requirement might have come from an intern who left 2 years ago. It just exists. You must attack the requirements. Every requirement must have a person who owns it, someone who is personally accountable. If not, it should be deleted. Step 1 is absolute skepticism about the rules. Step 2, try very hard to delete parts or processes. I think this is the most important one. As humans, we have a natural bias to add a step, add a rule, add a part, add more people. We think complexity is smart. No, complexity is the enemy. At SpaceX, I tell the engineers every part on the rocket, every process in the factory must fight for its life. Ask, is this part necessary? Delete it. If you are not occasionally adding things back that you deleted, then you are not deleting enough. This is a constant war against entropy, against creeping complexity. Delete, delete, delete. Step 3, simplify or optimize. You only do this after you have deleted. This is the trap. The most common error, probably the most common error of a smart engineer, is to optimize something that shouldn't exist. They work so hard. They sweat, they stay up late to improve a part, to make it 10% lighter, a part that should have been deleted in step 2. Don't optimize something that's dumb. Only after you have attacked the requirements and deleted everything you can are you allowed to simplify and optimize what's left. Step 4, accelerate cycle time. You can always go faster. Once you have a non-dumb, simplified process, then hit the accelerator. How can we do this in a week instead of a month, a day instead of a week? Speed is everything. Fast cycle time means you can iterate more, you can fail more, you can learn faster. Step 5, automate. This is the last step. Do not automate something that's dumb. Do not automate a part that should be deleted. Do not automate a complex process that should be simplified. We made this mistake. We made this mistake badly at Tesla during the Model 3 ramp. I was too confident in automation. We tried to automate everything too early, and we automated things that humans do very easily and robots do very badly. You have to get the process right first, then you accelerate, then you automate. This 5-step algorithm, it's the execution. It's how you take a first principles theory and make it real. It's the machine for manufacturing probability. The cost probability, bankruptcy, hell, and never give up. But manufacturing probability, it's expensive, it's not free, it demands everything. I want to tell you about 2008. We started SpaceX in 2002. We'd been at it for 6 years. Falcon 1, our first rocket, our first launch 2006, failure, engine fire right after leaving the pad. Rocket came back down and slammed into the ground. Second launch 2007, failure. It got higher, but then it started oscillating, lost control, blew up. Third launch, August 2008, failure. This one hurt. The first stage worked perfectly. The new Merlin 1C engine, the one we would use for Falcon 9, it worked beautifully. But a problem with stage separation. They didn't separate cleanly. They collided. The upper stage lost control. 3 failures in a row. We were out of money. I had put $100 a million of my own money into SpaceX. The entire proceeds I made from PayPal. It was enough for 3 launches. And all 3 had failed. And as if that wasn't bad enough, it was 2008. Tesla was also dying. The global financial crisis hit. The credit markets froze. People were panicking. General Motors and Chrysler went bankrupt. And we were a tiny electric car startup trying to raise money in the worst environment since the Great Depression. I had invested about $70 million into Tesla. Everything I had was in these 2 companies. And both of them were on the verge of bankruptcy. At the same time, I was out of money. I was tapped out. I had enough money left for one last launch of the Falcon 1, just one. And I had to face a choice, a terrible choice. I could put all the remaining money into one company and let the other one die, or I could split the tiny amount of money left between both. It was a really, really hard decision. They were like my children. I couldn't choose. I couldn't let one of them die, so I split it. I split my last remaining funds to try and keep both alive. But that could have been a terrible decision. It could have meant both companies would die. I never thought I'd have a nervous breakdown, but I was. I was very, very close. Every day I woke up and every day I went to sleep was extreme pain. At Tesla, we were trying to close a financing round. We were out of cash. We couldn't make payroll. That financing round, it closed at 6 p.m. on December 24th, 2008, Christmas Eve. It was the last hour of the last possible day. If it hadn't closed, then payroll would have bounced 2 days later. I had given Tesla my last dollar. Everything I had left from PayPal. I didn't own a house or anything sellable. I had to borrow money for rent. Why? Why do that? Why risk everything? Because it's important. Because there's another philosophy it goes with the possibility-probability one. If something's important enough, even if the odds are against you, you should still do it. A sustainable energy future that is important. Becoming a multiplanetary species, that is important. They are important enough to be worth risking everything for. After the third Falcon 1 failure, when things looked darkest, I sent an email to the whole company at SpaceX. I told them I knew it was a massive disappointment. But there should be absolutely zero question that SpaceX will prevail in reaching orbit and demonstrating reliable space transport. And I ended the email with a promise. I said, for my part, I will never give up. And I mean never. And we didn't give up. September 2008, just 1 month after the third failure, we put every last thing we had into the fourth launch of the Falcon 1. If this one failed, SpaceX was over. It worked. It reached orbit. That was the moment. The first time in history, a private company had successfully built and launched a liquid-fueled rocket into Earth's orbit. A few days later, NASA called. They gave us a $1.6 billion contract to resupply the International Space Station. That contract saved the company. That was the moment. The first step is to establish that something is possible. Then probability will occur. That decision in 2008, that was the ultimate test. I didn't bet on hope. I bet my financial existence on my physics calculation. I bet that the first principles were right, even when my first 3 rockets and the entire financial market were all telling me I was wrong. Scaling impossible, production hell, and the lesson of the factory. So we survived. SpaceX learned to fly. Tesla learned to mass produce. And then we hit a new kind of impossible. It was scale. People, they criticize me. They say I'm too optimistic with my predictions. They say I'm always late, and they're right. I have an issue with time. But I specialize in turning the impossible into merely late. At Tesla, we announced the Model 3, the affordable electric car, and the demand was insane, hundreds of thousands of pre-orders. We had to scale production from tens of thousands of cars to 500,000 cars a year. In 2018, we set a goal of 500,000 cars. That was a 10x increase. Everyone in the auto industry, they laughed. They said it was impossible. They called it production hell, and it was. It was absolute hell. I was living in the factory. I moved my desk to the worst spot in the factory, right at the end of the production line. I had a sleeping bag in a conference room right next to the production floor. I slept on the factory floor, not because I enjoy sleeping on factory floors. I don't. It was because I needed to be in the feedback loop. This is a key lesson. They have no real visceral incentive to solve the problem. You must put the engineers right next to the line they're trying to fix. You have to make the factory's pain their pain. But the bigger question, why? Why set an impossible goal in the first place? Why put yourself through production hell? Because if you set a comfortable goal, you will achieve it comfortably. You will reason by analogy. You'll just tweak the old process. But if you set an insane, impossible goal, like a 10x increase in production, you force people to think from first principles. You can't copy the old way and get there. It doesn't work. You have to break the old process. You have to create serious pressure. Production hell was a deliberate macro scale application of the "if you're not failing, you're not innovating enough" mantra. We were intentionally breaking the system at the factory level to force innovation at the factory level. We applied the 5-step algorithm not just to the car, but to the factory itself. And we learned the most important lesson of Tesla, the new impossible frontiers, Optimus, Neuralink, and consciousness. So all of these things, they are connected. Tesla is about accelerating the transition to sustainable energy. We have to solve climate change. It's an insane experiment we're running with the only atmosphere we have. SpaceX is about becoming a multiplanetary species, a life insurance policy for consciousness, Starlink connecting everyone on the planet, especially those who are unconnected, and then there are the next frontiers. The next impossibles, Optimus. The impossible supply chain problem. We are building a humanoid robot called Optimus. The goal is a general purpose humanoid robot that can do basically anything you don't want to do, dangerous, boring, repetitive jobs. This is an extremely difficult engineering challenge. The hand and the forearm, they're more complex than the rest of the robot. But what's the real impossible challenge? It's not just the design. The challenge is there is simply no supply chain for humanoid robots. No one makes the actuators, the sensors, the motors at the scale of millions of units per year. It doesn't exist. So, sound familiar? Just like rockets, just like batteries. We have to do it ourselves. We have to vertically integrate and create the supply chain from first principles. We are taking the engineers who designed the actuators for Tesla vehicles, and they are now designing the actuators for the robot. It's the same pattern all over again. People say it's impossible. We say, does physics allow it? Yes. Okay. Then it's just an engineering problem. Neuralink, redefining human, and then there is Neuralink. This is another level. Tesla and SpaceX, they redefine what future humans will do. They'll drive electric cars. They'll fly to Mars. Neuralink wants to redefine what future humans will be. This is perhaps the most audacious, the most grand. The initial goal, the immediate goal, is medical. Helping people who are paralyzed, people with spinal cord injuries, restoring their mobility, restoring their autonomy. Helping people who are blind to see. Helping people with severe neurological diseases. And we are making progress. But the long-term goal is about the future of consciousness. We are at the dawn of a new era. We are facing the rise of digital superintelligence, artificial intelligence. And we have a problem, a fundamental problem. It's bandwidth. Your communication rate with the digital world, what is it? Your communication rate with your phone, with your computer, it's insanely slow. You type with your fingers, you speak. It's maybe a few hundred bits per second. A computer can communicate at gigabits, terabits per second. There is an orders of magnitude difference. If AI, when AI becomes super intelligent, how do we keep up? We will be left behind. We will be like house pets, like a house cat. I don't like that future. The only solution I can see is to create a high bandwidth brain-computer interface, a tertiary layer for your brain, a merger to become a human-AI symbiote, where the AI is an extension of yourself, not something alien and separate. This is one of the biggest impossible problems. We hit a technical problem recently, crazy one. We needed to compress the data from thousands of electrodes. We needed a lossless compression rate of over 200x. It had to work in real time, and it had to be extremely low power because it's in your brain. The experts, the software consultants, call that outlandish. Sound familiar? It's not outlandish. It's just another first principles problem waiting to be solved. The imperative of possible. So we come back to the beginning. Why do all this? Why risk bankruptcy? Why sleep on the factory floor? Why go after problems that everyone says are impossible? Because it's important. Because I think about the future and I don't want to be sad. I want an exciting future. I want a future where we're excited to wake up in the morning, and there's a bigger picture. Earth is 4.5 billion years old. In that 4.5 billion years, life is still not multiplanetary. It is still stuck on this tiny blue rock. Life consciousness is a very rare and very precious thing. It is the light of consciousness. And it is very fragile. The history of life on Earth has seen 5 mass extinction events. Eventually something will happen to Earth. Hopefully not soon, but it will happen. It could be natural, an asteroid, a supervolcano, or it could be man-made, climate change, an engineered virus, nuclear war. The history of civilizations, there might be a lot of filters. And we are approaching what's called the Great Filter. It's a theory to explain why we don't see aliens everywhere. The theory is there is some wall, some filter that civilizations cannot pass. Maybe they always destroy themselves before they can become multiplanetary. Maybe they always create an AI that eventually replaces them. I see 2 great filters in front of us. SpaceX is my answer to the first filter. Becoming a multiplanetary species. If we can establish a self-sustaining base on Mars, we will have passed one of the greatest filters. We will have dramatically increased the probable lifespan of consciousness. Neuralink is my answer to the second filter. Merging with AI, ensuring that the future is controlled by a combined human-AI consciousness and not an alien one. So we go back to that quote. The first step is to establish that something is possible. Is it possible to preserve the light of consciousness? Yes, physics allows it. Is it possible to become a multiplanetary species? Yes, physics allows it. Is it possible to create a sustainable energy future? Yes, physics allows it. Step 1 is done. The rest is just engineering. The rest is our job, is your job. When you go home tonight or tomorrow, when you see a problem that everyone says is impossible, don't believe them. Don't reason by analogy. Ask what are the first principles. Boil it down. Find the physical truth. Because impossible is usually just a word that people use to mean a very hard engineering problem that no one has been brave enough or crazy enough to solve. Once you prove something is possible, you have an obligation, you have an imperative to make probability occur. Thank you.